Hey guys, today we will be doing section 12.2, focusing on direct substitution and indeterminate form. So I'm just going to dive right into it because it's kind of a lot. So hopefully you print it out or have the fill in the blank notes. For limits of continuous functions, we can use direct substitution. Simply substitute the x value into the function. So use direct substitution if possible to evaluate each limit. Now that should make sense, right? Sorry. A continuous function, right? Like a quadratic, for example. This isn't a quadratic, but for a quadratic, there's not going to be any discontinuity. So it makes sense that the limit is going to actually be whatever the function is. So let's just do a couple examples. Oops. This is basic algebra, should be super easy. I don't even think I'm going to do all of them. I'll probably pause the video and just show you guys the answers. So I'm telling you, use direct substitution. You guys might not know every continuous function, so you could substitute like the equation into your calculator and see, although that doesn't always work because sometimes your graphing calculator will look like it's continuous, but there's a hole in it. Anyways, so 2 to the 4 times 2 minus 4 times 2 plus 1. I just put that on my calculator. It's 25. 2 plus 3 is 5. So this is 5. So the limit, you could rewrite this if you want. So the limit as x approaches 2 of f of x, that function, is going to be 5. Okay, so example 2, same idea. Use direct substitution. -7 plus 5 is -2. And hopefully you're like, wait, that's not possible. And you're right, because it's square root of -2, so this is not possible. So you could determine it does not exist. All right. And then that should make sense for that function, right? If it's a square root function, remember it looks like this, and it's being translated right 5. So at -7, there's going to be nothing on the graph. All right, so I'm going to pause the video and do both of these examples. I recommend you pause the video too and then hit play, and the answers will be there and I'll go over them with you. Okay, so for A, hopefully you got -92. If you didn't, probably just made a really silly mistake, so just be careful. And then for B, you should have got 0 over 0, and that's not possible because you can't divide by 0. But here's the thing, this is actually a really special case. This is what we call, this is the indeterminate form. Oop, that was weird. Indeterminate form. The next step, which we're going to do on the next page, would be to factor. And then I'm just going to say see next page. And let's talk about it. So suppose you incorrectly applied the quotient property of limits or direct substitution. So we just did direct substitution. Here's applying the quotient property, right? You get 0 over 0. It's customary to describe the resulting fraction 0 over 0 as having an indeterminate form. Because you cannot determine the limit of the function with a 0 in the denominator. However, a limit of this type may exist. So just because you use direct substitution doesn't necessarily mean if the limit doesn't exist. So if you get 0 over 0, that's the indeterminate form, and that kind of lets you know, like, oh crap, there might actually be a limit, and have a real number value, or it might not exist. But now you have to do more. So if you evaluate the limit of a rational function and reach the indeterminate form, you should try to simplify the expression algebraically by doing your favorite thing, factoring. Hopefully you guys are getting more comfortable with factoring, and dividing out the common factors. So this is the exact same example. We got the indeterminate form, so now you gotta do more work and go, okay, well, it's indeterminate, so I need to now determine, does a limit actually exist or does it not? So the numerator has a quadratic. I'm going to factor that, and this is a difference of squares, so that's x plus 1 times x minus 1. And then because we have an x plus 1 in the numerator and multiplication, and then an x plus 1 in the denominator, these are going to cancel, and we're left with x minus 1. So now I can redo and use direct substitution. So that's going to look like -1 minus 1, which is -2. So this is indeterminate, but it does have a limit. So the limit as x, I just sounded like a weatherman, but it does have a limit. Oh boy. So the limit as x approaches -1 equals -2. Okay, so for direct substitution, you should try to direct substitute and see if it works, and then if it doesn't, see if you can factor. So you guys try to do this. I'm going to pause the video and do the work, and then hit play once you're done. Alright, so this is an indeterminate form, so you have to factor, and then once you factor, you can cancel your x minus 6 factors. You're left with x minus 1 over 3x plus 7. So now from here you can use direct substitution and see if it does work, and you should get 1/5. So that means the limit as x approaches 6 of this function, which I'm just going to call f of x, equals 1/5. And that's it for today. Feel free to come to Flex Time if you have any questions, and I hope you enjoy the rest of your day.